So here we go with the last set of questions. I hope I can get them all in about 10 minutes. Number 26, identify the sublevel in which the electrons n equals, with the quantum numbers n equals 5, L equals 3 are found. So n equals 5 is just 5 over here. L equals 3 means the F sublevel, as we've already discussed. So we're looking at choice B for the answer. Oops, not choice G, choice B for the answer there. Number 27, given a corresponding, so we know we're looking for the set down here that matches what's up here. So here we have 2 with an S sublevel, n equals 5 with a D sublevel, n equals 3 with a P sublevel. Remember, L equals 0 is S, L equals 2 is D, and L equals 1 is P. So we'd look for 2S, something that starts with 2S. There's only one of those that does, so we can stop right there, and it's B. The most easily removed electron in a gallium atom in its ground state. I'm going to write the configuration so you can see this. So it'll be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. At that point, I've got 30 electrons. So if I'm going to do this one properly. So we'll superscript them all. Remember to find the number of electrons in the electron configuration. You need to add all these numbers. So 2 and 2 and 6 and 2 and 6 and 2 and 10 makes 30 electrons. Gallium has 31 electrons per the periodic table. So we need to go ahead and add the 4s or 4p1. That would be next. So the most easily removed electron would be the one that has the highest, it's in the outer shell with the highest energy. The outer shell with the highest energy. So in this case, that'd be 4p1. So you're looking for n, well, that becomes easy then because there's only one n equals 4 electron. So the answer is B. A little caveat here, something you might want to remember is if we were talking instead about zinc, which is that element. If it was zinc, which electron would be the most easily removed, it would be the 4s electrons. Because the electrons in the outer shell, the highest value of n, are the ones that get lost. So remember, if you've got a S and 4s3d or 5s4d and so on, it's the s electrons that come off first. All right, number 29, n equals 4. So if n equals 4, what's L going to equal? L could equal 0, 1, 2, 3. So there'd be 4 different sublevels associated with that. The answer is, of course, then D. Total number of orbitals in the n equals 2 level. In the n equals 2 level, you've got a 1s, or so we have 2s, and a 2p. The s sublevel has only 1 orbital. The p sublevel has 3 orbitals. That's why it holds 6 electrons, 2 electrons per orbital. So we have a total of 4. So the answer would be D. The most unpaired electrons. I'm going to write the answer is iron plus 2. I'll write down the number of electrons unpaired in each one, and you can see if you can figure that out. Aluminum has 1 unpaired. Sulfur has 2 unpaired. Phosphorus has 3 unpaired. Barium has 0 unpaired. And iron has 4 unpaired. Oops, but you don't need to make that in a superscript, so we'll put that back down. 4 unpaired. Here's why. Electron configuration of iron: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So the electrons that get lost when it makes plus 2 are these 2 electrons, leaving us with a d6. All right, so they're gone, and we're just left with a d6. Now, if we have a d6, there are 5 orbitals in a d sublevel. So the first, you'd go 1, 1, 1, 1, 1. That's 5 electrons. Then you had to come back and make this a 2 for the 6th electron. So how many unpaired do you have? 4. And that's why iron is 4. That's why iron is the correct answer for that. E. All right, how many unpaired are there in copper? In copper, I did earlier in the test, so let's go back up to that configuration. Thought I did copper earlier in the test. Yeah, here we go. So copper we did in the D sublevel. It's got 29 electrons, so it's one short of having 30. So it should be a 22221. So it'll be one unpaired. It really is a 22222 in the D sublevel. But if it becomes 22222, one of the 4s gets promoted. Instead of 4s2, it becomes 4s1, and then a 3d10. So the unpaired electron in copper is actually this one, but if you thought it was this one, you'd still get that question right. So the answer for the number of unpaired electrons in copper is 1. All right, and we did that one. Here we go, 1. All right, which set is not allowed? If n equals 2, can you have a 2s sublevel? Yes, and if you have an s, L equals 0 is fine. 3s, but if L equals 0, you can't have a positive 1 m value, so that one is wrong. If n equals 3, can you have a d sublevel? Yes, and if you have a d sublevel, you could have a negative 2 orbital because the values would go from negative 2 to positive 2, so for L equals 2, m could equal negative 2, negative 1, 0, 1, 2. So that one's okay. If n equals 1, L cannot equal 1 because L only goes from 0 to n minus 1. So that one's wrong. If n equals 2, L equals 1, that's 2s. And if you have L equals 1, m can equal 0, so that's fine. So the best answer then is 2 and 4. The answer is A. Those are the ones that are wrong. Which one's not allowed again? 34. So you got a 2p with a 1. That looks fine to me. You've got a 2p where m's positive 1. Same thing, really. So that's fine. And the electron could be spinning the other way in that positive 1 orbital. It's fine. You got a 3, 2, negative 3. That one's not good because if L equals 2, m can't equal negative 3. It can only be negative 2. So that one's wrong. Down here, you got a 2s. So that one looks fine. That means this one must be wrong. So you got to, yeah, that's incorrect. Because if you have a 2s, you can't have an m value of positive 2. So the answer would be E, 3 and 5. 35, the most easily removed electron from potassium in its outer state. If you look at the periodic table by now, you should be able to know that potassium's last electron is 4s1, based on its position in the table. So there's 4s only shows up here. So the answer would have to be B. The last electron, once again, is the easiest removed. The last outer shell electron is the easiest removed. 36, give the corresponding atomic, okay, so this would be a 3D, and that would be a 5F, and that would be a 4P. So 3, looks like the answer is E. The type of orbital occupied by an electron with a quantity 5s, and there's only one 5s orbital. So 5s and 1, E. There's only one s orbital in any given energy level. Number 38, the type of orbital that can be occupied by an electron with the quantum numbers n equals 5, L equals 3. How many orbitals? That'd be 5f, 5f, and there are 7 orbitals because m can be negative 3, negative 2, negative 1, 0, 1, 2, 3, as we said earlier, so that'd be D. 39 and 40 were math problems. I'm going to let you work those out. C is equal to lambda nu for the first one. Oops, I got my caps lock. That was a capital letter in Greek, and nu. C is the speed of light. So you know this number, and you know the wavelength, and it's conveniently already in meters for you. So all you have to do is solve for the frequency. The answer, if I remember right, was E. And number 40, you're looking for energy again, so you're going to use this equation. E equals h nu. So E equals h, oops, got to change out of my Greek alphabet. H, now back into the Greek alphabet, nu. So E equals h nu. We know h is 6.63 times 10 to the negative 34th joules per hertz. We know the frequency is 4.2 times 10 to the 14th hertz. Also, once again, the units conveniently work out. And if I recall, I believe the answer is E again. But you can work that out and double check. And that's the end of this test review. So hope you're studying this, and hope you do well on a retake if you need to do that.